Tonight's topic is all on multiplying radicals. So let's begin with the multiplication property of roots. A radical b times c radical d is equal to a times c radical b times d. Okay, so let's get that in our notebook highlighted, a times c radical b times d. So here's the key. When multiplying roots, multiply the numbers outside of the root together and inside of the root together. Then simplify. So again, I'm going to multiply the outsides, the a and the c, to make a times c, and then the insides, b times d. So let's look at a few examples. Number 1, radical 2 times radical 50. So the rule says we're going to multiply first, the numbers outside and inside. Well, remember, technically there's a number 1 in front of these radicals, so I get 1 in front of this radical. Square root 100. And hopefully we know that answer is a nice even 10. Example 2, 5 radical 6 times 3 radical 2. Well, the multiplication rule says we're going to multiply the outsides. So outside I'm going to get 15, and underneath my radical I'm going to get 12. Now the only thing is you're just not done there. Now you just simplify radicals like you've been doing. We're going to leave the 15 in front, and we're going to break 12 down. 12 multiplies to 4 times 3, and then I'll say to myself, okay, I know the answer to radical 4 is 2, so I have 15 times 2 radical 3. So now again the numbers outside get multiplied together. Notice there are no plus signs in this problem, so I would say 30 radical 3. Example 3. Maybe a little uglier with a fraction, but nonetheless the same idea. Multiply the outsides, so outside 15, and then we'll multiply the insides. 1/3 times 27. Well, off to the side I'm just going to say that's 1 over 3 times 27 over 1. So that just makes 27 over 3. And hopefully we know that's 9. So now I don't need to break 9 down because I know that answer. I know the square root of 9 is 3. So 15 times 3, a nice 45. Alright, example 4. Now all we did was throw some variables under there, and we're still going to apply the same property. Multiply the insides, multiply the outsides. So outside, again, I technically have 1. Inside, my 5 times 4 gets me 20. And when I multiply, remember, I add exponents. So I'm going to say that's x to the 9th. Now, we're pretty good at breaking these down. We've done this before. Again, I'm going to start with my 20. So I'm going to say that's radical 4 times radical 5. And because this is a square root, I need everybody to be in squares. So x squared, x squared, x squared. That gets me 2, 4, 6. Here's 8, and I'll have 1 left over. And now I'll just go through and say, okay, the square root of 4 is the number 2. I'm going to leave the radical 5. That became an x. That became an x. That became an x. That became an x. This can't get broken down, so I'm going to leave radical x. Now remember, you just multiply the terms outside and the terms inside together. So I have 2x to the 4th radical 5x. Okay, and again, when you multiply, the things inside stay together, outside stay together. How do you know if you're right? Well, just ask yourself, can this get broken down any further? Can you break 5 down? No. And x is already simplified. Alright, number 5. So they're going to get uglier as we go through. What does your gut tell you to do when you have one term in front of parentheses? Hopefully that gut of yours is saying distribute. Okay, so all I'm going to do is take this term outside and I'm going to distribute it to each term. And just use that same property. Multiply the numbers outside together and inside together. So on this first one, I have a 1 times a 2. So there's my 2. And my radical is 6 times 6, so that's radical 36. Minus, again, the outside, so minus 4, radical 12. Now I'm going to go ahead and break that down. Do you have to break 36 down, or do you know the answer? Well, hopefully you know the answer is just the number 6. Minus 4, now I have to break 12 down as 4 times 3. Remember, you can't use 6 and 2. Those aren't perfect squares. 6 times 2 here is 12 minus, this becomes a 4, that becomes a 2, and that becomes a 3. So I would say minus 8 radical 3. Now you'll notice I don't have like terms. I can't add those together. However, If this had a radical 3, then I could add them. But again, they're not like terms, so we're just done there. All right, how about this one? The quantity 3 radical 5 plus 3 squared. What does it mean to square something? What does it mean when somebody says 4 squared? We all know the answer is 16, but what does it actually mean? Well, it means take that number that you have and multiply it by itself. So I need to write this down and multiply it by itself. You don't just square two terms. You rewrite it, like we just said, and multiply it by itself. Okay, so now I don't have a distributing problem. I have more of a foiling type problem. So I'm going to take this first term and multiply it here and here. So again, the outside terms go together times the inside terms, so times 25, plus, now I'm going to do this last one, so that's just going to be 9 radical 5, plus I'm going to do this inside, 9 radical 5, and this last term, so plus 9. Okay, so again, just multiply the outside pieces and the inside. Alright, we'll clean her up. So the square root of 25 is just the number 5, so this gets me a 45. 9 radical 5 plus 9 radical 5. Notice the radicals are the same, that means you're allowed to add them. And again, you're only adding the numbers out front, so I'm going to call that 18 radical 5. And then I have a plus 9, so I can add my like terms one more time. Excuse me. So that gets me 54 plus 18 radical 5. Then again, I'm finally done there because I don't have like terms. Alright, why don't you pause this one, try it. Very similar to the last one. We're obviously not squaring it, but we are foiling. So pause it, good luck, and then we'll compare answers. Pause it. So you can see I foiled my term out. I know that this number is the number 5, and that gets me a total of 30, and when I put that minus 3 together, I've got 27. Negative 3 radical 5 plus 6 radical 5, again, they're like terms, so I'm only adding the numbers in front, so plus 3 radical 5. Now, I can't add them together. Technically, I'm done here. Perhaps this isn't the multiple choice. You could pull a GCF out. When I do the GCF, though, you're never using the radical itself, just the numbers in front. So I could say this is 3 times 9 plus radical 5. Would you agree with that? It would take 2 seconds to check. 3 times 9 is 27, and 3 radical 5 is 3 radical 5. So again, you don't have to, but I just want you to know, in case you didn't see that as a multiple choice answer, that it is equivalent. Okay, hopefully you've caught on to this. Any radical multiplied by itself is simply the number under the radical. Now, that only works if you're multiplying a number by itself. For example, radical 3 times radical 3 is equal to radical 9, which is really just the number 3. So hopefully by now you can say radical 3 times radical 3 is just going to be 3. Likewise, radical 5 times radical 5, do you actually have to do it in simplify, or should you know that it's just going to be 5? Radical 10 times radical 10 is just going to be 10. Radical k times radical k is just k. So again, this only works if the number is being multiplied by itself. The next big term is the conjugate. Now we've heard this before, but we're going to deal with a lot of it in radicals. So let's say the conjugate of radical a plus b is radical a minus b. So if you haven't caught on to the word conjugate that we've used, like I said, a few times this year, let's be very clear. The only thing that's changing is the sign in the middle. Okay, we're not messing with the first term. Okay, we're leaving the first term, so radical a and radical a stay the same. It's just the sign in the middle that changes. So let's just practice a few conjugates. If I said negative 4 plus radical 2, the conjugate would be negative 4 minus radical 2. You leave the first term, you're only changing the sign of the second term. And this doesn't even have to be with radicals. If I said x minus y, its conjugate is going to be x plus y. Okay, you're just changing the sign of the second term. let's give one a whirl here. Multiply 6 radical 3 plus 2 by its conjugate. Okay, so the first thing I do is I write down 6 radical 3 plus 2. And now I'm going to say the conjugate of that is leave the first, 6 radical 3, minus 2. Change the sign in between them. Alright, so let's go ahead and multiply. First, the outsides give me 36. Are you quick enough here now? Radical 3 times radical 3, we just said is going to be the number 3. If you want to write radical 9 and then simplify, that's up to you, but hopefully you understand any radical times itself is just that number. Minus these last terms, so that's going to be, the outside is 12 radical 3. The inside is going to be plus 12 radical 3. The outside is going to be minus 4. Okay, so now I can multiply here. 36, 6 times 3 is 18. Carry the 1. That gets me a 108. What do you notice about a negative 12 radical 3 and a positive 12 radical 3? You're right, they cancel. So that's gone, and then I just have minus 4. So I get a 104. Well, that's really nice that they cancel. Do you think that works every time on a conjugate? Let's take another quick example and find out. What if I said 4 radical 3 plus 2? Multiply that by its conjugate. So 4 radical 3 plus 2 times 4 radical 3 minus 2. Alright, well let's see what we get. Let's start on those outside terms. So that's going to be 16 times 3. Radical 3 times radical 3 is just 3. Minus 8 radical 3 plus 8 radical 3 minus 4. Look at that. Happens again. Minus 8 radical 3 plus 8 radical 3 gone. And I'm left with 48 minus 4, which is just 44. So what do you think? I think we can make that statement in our notebook. So when you multiply conjugates, the middle two terms should always cancel. Okay, so I just want to be clear that only works if they're conjugates. So let me be sneaky. What if I said 2 radical 2 plus 1 times 2 radical 2 plus 1? Should the middle terms cancel? Are they conjugates? Well, they look the same, but notice the sign in the middle is the exact same. So they're not one's positive, one negative. They are not conjugates. So in this case, the middle term should not cancel. You should have all 4 terms. We can prove that real quick. Outside, I get 4. Radical 2 times radical 2 is just 2. Plus 2 radical 2 plus 2 radical 2 plus 1. Notice these are not going to cancel because they're not conjugates. All that's going to give me is 4 radical 2. Here I'm going to get 8, so 8 plus 1 is 9, plus 4 radical 2. They will only cancel if they're conjugates. Well, I think that does it for us on multiplication. If anything went too fast, go back, pause it, rewind it. But the main idea we want to keep in mind is we're going to multiply outside of the radical and multiply inside of the radical. Have a great night.